So the second question in the tutorial, or the second part of the exercise that we saw earlier, is going to be about the shear stress in the machining. So we're going to continue with the question. We're going to take the data that will be useful to do the calculation for the shear stress. And we are going to start with the cutting force of the thrust, and the thrust force are going to be measured during the orthogonal cutting operation, where the cutting force is equal to 1,559 Newton, and the thrust force is 1,271 Newton. The width of the orthogonal cutting is given to be 3 millimeters, and based on these data to determine the shear strength of the work material. Remember that we are continuing from the previous question where we had the value for the phi and the value for the gamma. So let's have a look about the force analysis, force and stress analysis in the cutting operation. So from the photo you can see in front of you, we can see that we are going to have different types of the forces that acting on the chip during the cutting operation. These are including, as you can see here, we have the thrust force, and we have the friction force, and we have the shear force. So the friction force is going to be the one that resisting the movement of the chip, which is going to be between the tool and the work part. That's the friction force. And the normal force to the friction force is going to be the end, perpendicular to it. We have the shear force, which is the force that resisting the shear cutting of the chip from the part. And we have the force that normal to the shear force. Okay, so now these are the forces we are going to have. You can see that these forces are not related by any way, except that the resultants are going to be equal in magnitude and opposite in direction. So the resultant forces, the vector addition of the friction force and the normal force to the friction force is going to be resultant R, and the vector addition of the shear force and the force normal to the shear force is going to be resistant R prime. So the force acting on the chip must be in balance, so the R prime must be equal to the magnitude to the R, and the R prime must be opposite direction of the R, and the R prime must be collinear to the resultant R. The coefficient of friction, or the mu, okay, is going to be equal to the friction force over the normal force. And also it can be calculated by using the friction angle beta. So the tangent of the beta is going to be equal to the coefficient of friction. The shear stress value, or the S, or the tau S. If I know what the cut length, or the length of the shear, and I know what the value for the width, I can calculate the area of the shear. So the length of the shear is going to be equal to the TO, or the initial thickness of the chip, divided by the sine of the phi, or the sine of the shear angle. So the tau S is going to be equal to the shear force divided by the area of the shear. The area of the shear is going to be equal to the initial thickness multiplied by the width divided by the sine of the phi. The shear stress is equal to the shear strength of the work material during the cutting operation. So now let's go back to the same equation. Remember that we calculated the value for the phi from previous question. The TO is given as 0.5, the W is given as 3 millimeters. The shear force is already been given, and we can calculate the value for the tau in that case. So let's go back to it. You can see that we have the cutting force and we have the thrust force, not the shear force directly. So we start to do the calculation. The shear force is going to be equal to the cutting force multiplied by the cosine of the phi minus the thrust force multiplied by the sine of the phi. By applying the parameters in, I will get the value for the shear force is going to be equal to 863 Newton. You can find this equation for the shear force and the other forces available on the slide of the tutorial. Now, next step, after we found the value for the shear force, we need to find the value for the AS, or the shear plane area. So it's going to be equal to the initial thickness multiplied by the width divided by the sine of the phi. 0.5 is the initial thickness, 0.3 is going to be the width, and we have that the 5 is 25.4, so the area is going to be equal to 3.497 millimeters square. So that's it. I just need to find the value for the tau s, which is the shear stress, and this will be equal to the 863 divided by 3.8497, and this will give me 247 Newton over millimeter square, or what is equal to 247 megapascal. That's the answer for the question, and then we're going to move to the next part.